Hello everyone, welcome to MySQL QA episode number 11. Today we'll have a look into Valgrind testing. Pros, why, cons, how, etc. My name is Roel van der Paar and I work for Pergona. If you haven't seen the previous episodes, I could suggest you go and have a look at those. So MySQL QA episode 1 was all about Linux, Bash, scripting, 13 parts to it. You can select which parts you want to watch. It starts very easily with ls and it goes all the way up to Xarcs, etc. MySQL QA episode 2 was all about building a MySQL server using Git, compiling, build tools, etc. MySQL QA episode 3 was about GDB and debugging, 1.5 hours of debugging fun. So if you've never worked with GDB or you need a refresher, that'll be a great one to watch. Episode 4 was about setting up the QA framework, only a very short episode, but good to get a slight introduction. And then episode 5 and 6 go further on episode 4 with the same run and getting everything set up, analyzed, filtered, all the way down to getting everything ready for logging a bug on the MySQL website. Episodes 7 to 9 are all about Reducer, so in 3 different stages. The first episode contains a lot of information. It's about an hour and a half, and it gets you started on using Reducer. For many that will be enough, but for those that are in QA, you probably want to watch episodes 8 and 9 as well. Also for those that are in QA, how to reproduce and simplify, how to get it right. And so this continues in a way on how to use Reducer, etc. For the really difficult cases where a particular issue doesn't reproduce, etc. Then we have this episode all about Valgrind, and for the next episode I'm still not sure whether I'll go with multi-node cluster testing using Docker or my server is crashing now what, because it would be interesting for customers or users experiencing a crash to get that information. Finally, there's episode 13, and I may offer this to the guys at Oracle, the guys at MariaDB, our own team, and basically everybody who does any MySQL testing, whether it would be a feature or a new storage engine or the server itself or the optimizer. In it I'm proposing a very different way of testing, but from just years of experience and seeing various things, how we could do MySQL testing as a community and as organizations better for the future. So I'm looking forward to that particular episode. It's something that I've been considering for quite a while. Okay, so let's get started with Valgrind testing. If you will allow me to draw a little diagram. So here we've got 3 different binaries, and so each time when we're talking about this, we're talking about the MySQLD binary. So I'm not going to put it above all 3, but you get what I mean. And we're having here our optimized or GA build of MySQLD. Then we have our debug build, and then we have our Valgrind build. And if you don't remember what these are, you could go and have a look at episode 2 again, or you could simply follow along here and I think you'll get an idea too. So optimized and or GA build, so basically picture it maybe like this. We have an optimized amount of code, which is not the full MySQL code that's available, which has been compiled and completely stripped of anything that could slow the server down, right? So of course, a benefit from this is that it will run as fast as possible, but not so good thing about this is once we run into a particular crash, we're going to have to go through all sorts of loops and hurdles to resolve the stack trace that we are getting from the crash, right? So it will not be so clean as with a debug build, which has debug symbols, debug instrumentation available. So that's the first clear issue. The debug build has debug symbols available, which when the server runs into a crash or to an issue will allow us to see a very clean stack trace of exactly what it was that happened. With the optimized, we would have to go through a number of steps, and it would be somewhat tricky to get that information out correctly. So a Valgrind build has that same debug information, and it also has extra Valgrind instrumentation. So just remember that for a moment, and then we'll come back to that in a minute. So let's say that our optimized server has somewhere in the code the variable a should never be 5, and that might be one example that's there in the code, and a should never be 5. So of course it wouldn't be called a, and of course it wouldn't be 5, but you get what I mean. A particular assertion that the developer is making, and he says, okay, at this point in the code, the variable a should never be 5. So if the server would run into this line of code and it says, hey, a is 5 here, then this server would crash, and it would give an overview in the error log, and it would write a core file if it was set up to do so, etc. But basically your MySQL would terminate. If you're using MySQL save, probably it would restart, etc., but that's not the point. The point is your server has crashed on a particular assertion. Now the debug also has this same assertion, right? But maybe it has additional assertions, and of course it does. So maybe the developer has said, hey, I'll make this a debug assertion. Now why would he make this one a debug assertion and a is not 5 an optimized assertion? Well, first of all, it could be due to a difference in severity. If a is not 5 at this point, maybe a is a very, very important variable and it should really never be 5, or maybe there's some data corruption happening. So that would be quite a severe issue. Maybe b is some sort of timer, and if b ever ran into 5, it wouldn't be very good. And something is still amiss, but maybe at the same time it's not really a reason for stopping an optimized server. So there's a lot more debug assertions that are present in the debug build that are not there in the optimized build. If we run our testing on the debug build, we're going to see more issues than if we run it on an optimized build. If we see, however, issues on the optimized build, of course they will have a higher severity than the ones on the debug build, and you will see this happening on the bug reports, people saying, oh, is this happening on the optimized build as well, on the build that we released, or is it just a debug assertion? Another reason could be where the developer is not so sure. For instance, he's been looking at a very complex piece of code, and that code is very historical, it's 10 years old, and nobody knows what it's doing, and it's involved locking and multi-threading, etc. And he's thinking, hey, look, according to me, b should never be 5 here, but I'm still not 100% sure. So I'm going to put in this debug assertion, and I know that the QA team is sooner or later going to test this build, and if they ever run into this, I want to know about it. So I'm going to follow all my bug reports, and if b ever ends up being 5, I'm going to debug that further, but for now I'll just say b should never be 5. And so I'll place that in the debug build, because I don't want all these customers suddenly to start running into some sort of assertion that I wasn't sure about to start with. Okay, so these assertions also exist in the Valgrind build, and that's fine. So you could consider a Valgrind build very often a debug build as well. You could probably make a Valgrind build based on the optimized, but I don't think that's ever done. Usually the Valgrind build is a debug build as well. So with the Valgrind, all of that is there, but there's something extra, and that's that Valgrind instrumentation here. So why do we need Valgrind instrumentation? What is that going to help us? So in the code there would be various memory allocation issues, and what if there is an error or a bug in one of those allocations? For instance, maybe it was supposed to release 5 bytes or something like that, but at some point the memory allocation went wrong and 5 bytes were lost. So that shouldn't happen, and it just means, not properly written code, or maybe even more serious, maybe there was some memory overrun or who knows what. So Valgrind instrumentation in combination with the Valgrind binary And so in this case we're no longer just talking about the MySQL D binary, but now we have the Valgrind binary, and this Valgrind binary works together with this extra Valgrind instrumentation to find these sort of issues. So we would be running the MySQL D binary under Valgrind, so your command line would be something like Valgrind and a little bit later on MySQL D, and in the background all this memory allocation stuff is happening, being checked. So the way that Valgrind does this, it runs this MySQL D, so just picture this MySQL D running on a virtual CPU. So instead of MySQL D executing directly against a CPU within your system, it's Valgrind executing MySQL D code on a virtual CPU. And this way, if something flows through that is not correct, of course Valgrind will be able to pick up on it. So that's in a nutshell, how Valgrind works. Now, there is a very big con here, but it's in a way also a pro, and I'll explain how that works. There's a 20 to 25 times, or that's just a number that I got in my head, but it might be slightly more or less, slowdown of Valgrind when it's running MySQL D. So for instance, a MySQL D startup might take 2 or 3 minutes. Now when you're executing thousands of lines of SQL code, you can divide that number by 20 or 25, and then you might get an idea as to how much longer you'll have to let a test run, simply to see that it runs exactly the same amount of SQL as you originally had in your debug build. And of course debug will also slightly run slower than optimized, because for example, it's already checking all these extra debug assertions, but there's not much difference between the two. With Valgrind running on a virtual CPU, there's a big slowdown, and that's not 20 to 25%, right? It's not 1.20 or 1.25, it's 2000 to 2500%. So it's literally 20 to 25 times slower. Why is this also a pro? Well, what happens is, because it's running so much slower, there is seemingly, and this is just from experience, more time to run into certain issues. At least that's my explanation for it for the moment. So when you're running a debug testing session, or when you're running a Valgrind testing session, you might run into different issues when you do the Valgrind session and end up with 2 or 3 bugs that you didn't see when you were running the debug build. And they might not necessarily be related to the Valgrind instrumentation. They might be, certain locking bugs or etc. My thought so far is that because Valgrind runs so very slow, it runs into situations that have never really been tested by any QA team before, in a way that if you're running random SQL, of course, sooner or later you're going to hit some issues, and if those issues are very significant and showstoppers, they'll be all over your QA run. But if they're minor ones, or things that are a little bit more hidden in the code and not so often hit, code paths that are not so often taken, then you're not going to run into a lot of the time. But because we're running so much slower, maybe there are issues that QA engineers have never run into before, or maybe there are certain things that the developers would have assumed, or maybe just missed, that they would have completed within a reasonable amount of time, but because of the slowdown, now they're not being completed in a reasonable amount of time. So this also gives us a bit of an advantage. If you're ever getting a bug within a debug build that's hard to reproduce, and maybe we would come back on that, on the reproducing and simplifying, but if you have a bug that happens in a debug build and you have a hard time reproducing it, just run into Valgrind. Not only might you start seeing Valgrind instrumentation errors, like or actual Valgrind memory allocation reports, but you might also see a crash more easily than with the debug build. So that's just basically a little tidbit from experience. Okay, so we've looked at the pros. The pros are obviously that we're going to see all the memory allocation issues. We're also going to see certain crashes that we don't necessarily see with the other builds. We're going to be able to do a few more nifty things down the road here with VGDB, but that's a different story. Okay, the cons, of course, we have to slow down, and we will have to adjust the length of our runs, and keep in mind that we're using Valgrind and that it's very slow. And of course our binary will be a bit larger as well, but that's not really a negative from a QA perspective. Okay, so let's have a look into how we can start using this. So the first thing you want to do is, I'm using CentOS 7 here, and you can simply install the latest Valgrind version. So I've already got the latest that's available here, 3.10. Or if you want to install it manually, the very latest, you could go and follow these instructions. Basically just go to the valgrind.org, have a look what the latest tar bzip2 tarball is, go and extract that, basically compile it and install it, right? So why was this interesting? Why would I even mention doing this? At some point you might start seeing certain things like this, unhandled instruction bytes, and then it would have some sort of hex address range, or like instruction set, sorry. And when you see that, basically what is happening, if you remember the virtual CPU there before, it's not able, at least that's my understanding of it, it's not able to execute a certain amount of code that it saw within the original binary. So this happened some time ago with MySQLD. Must have been using some sort of new I/O connection or something like that, and you would see this error, and of course that would be difficult to understand at first, but later on you could come to the conclusion, hey, I'm not using the latest Valgrind version, and because of that it's simply not able to understand yet what the binary is asking me to do here, what the original code is asking me to do here. So in those cases you would get the latest Valgrind. Those issues were back in the version 8 point something, so that's no longer there. But if you ever in the future see unhandled instruction bytes, go and upgrade your Valgrind version, run your run again. If you still see it, go and fetch the latest, or just enter this particular bit of code into Google, and you're probably going to end up finding that somebody already was aware of it or has already filed a bug report for it with the Valgrind guys for upgrading their virtual CPU code, which I assume is at the base of this. Okay, so that's if you wanted to manually upgrade Valgrind. So let's go back here. If you wanted to, you could go and have a look at the version like this and request some help for Valgrind like this. So you could have a look at it. It's not really necessary for this particular course, so I'll show you which options we'll be using and why we will be using them. But there are interesting things in here, like for instance trace child processes. Of course that's interesting if you have some sort of cascading between your processes or your binaries. That all makes sense, and you could have a look through here to find out a bit more information. First, I'd like to have a look at VGDB, and it's straight away adding a bit of complexity to that picture that we had before, but it's nonetheless interesting because it shows some nice interaction between 3 different tools. So if you remember when we were in the GDB episode, I think I might have shown it there at the end, we have our MySQLD binary, and in this case assume that we're talking about a running MySQLD binary. We're no longer talking about just having a MySQLD build, but in this case we're actually doing some live debugging, and we have GDB started with the bit option. In other words, And if you haven't looked at the GDB episode, maybe this would be a good point to do it. So we're connecting with the GDB to a live running MySQLD. You might remember that I think I gave the sleep example in the GDB episode where we connected with GDB into a sleep process that was running. I'm not going to repeat that here. You can go and look at that previous episode. But basically, we're using the debug GDB to connect to a running process, and that will be great because the process can be interrupted. We can set breakpoints, we can do debugging, we can watch stack traces, we can watch variables, and so on and so on and so on. So all that is great, but if you try to do this with MySQLD running under Valgrind, you quickly realize it's not going to be possible, because remember that MySQLD, so let me just start again here. So we have our Valgrind, and within Valgrind we have our virtual CPU. And that virtual CPU is running MySQLD. So if you were to go and do a process list, and we'll see that a bit later, on like for instance you say something like process list grep MySQLD, then you would only get a bounce back about the Valgrind process that's running. And at first that looks very confusing, right? You're looking everywhere, but you think, hey, but MySQLD is running. Why do I not see a process ID for MySQLD? Well, it's because it's running on this virtual CPU. It's running under Valgrind. It's completely gone. It's completely isolated. So MySQLD is no longer communicating directly with the hardware CPU. It's just running to Valgrind, and it's Valgrind who's communicating with the hardware CPU. So no wonder about the slowdown. But if we want to connect GDB, our little GDB tool again, then it looks like what will we do? Will we try and give this PID? Well, there is no PID, so will we give this PID? But if we do that, then we'll actually be debugging Valgrind. We won't be debugging MySQLD. So how do we get in here? So in a normal way, that's not possible. But Valgrind has a special tool which in a way allows us to do this. So we connect with GDB to Valgrind, and from there we can connect to MySQLD. In a way, what is happening here is Valgrind is starting this little server, and this little server is called VGDB. So now you can see what VGDB is doing. Valgrind is running this little server internally, and it's sort of proxying our requests through to MySQLD. So let's have a look at how this looks in real life. And for this we'll be using MySQL Test Run, the MTR tool from that's included with most of the MySQL distributions. So normally we would use this for doing regression testing, but in this case we're using this option start and exit, and we're just going to point it to the first test, and this first test is just a dummy test that doesn't really do anything as far as I remember, and we're just starting up MySQLD, and we're straight away exiting from the MTR test tool while we leave MySQLD running. So in a way it's a little bit like our startup script. If you remember the Percona QA startup.sh0, which you can run from any base directory, and that will create a start, stop, and client script, etc. The wipe script, you have to make that executable before you can use it, etc. Right? So if you remember it, it's a little bit like that. It's like creating that start script. So this is just a nice and handy way of doing it, and you get to see how that works too. It's like two flies in one swat. Okay, so let's have a look at this version of Percona server. So it's just a slightly older version, doesn't really matter for this particular exercise. Let me just check that I haven't got anything running. That's fine. And if you jump into the MySQL test directory, that's where it lives, and you check it out, there's the particular Perl little MTR script. And so we're going to say, let me just copy all of that at once, and I'll explain in a minute what all of these options do. Okay, so you know what the start and exit does now. Starts MySQLD, exits MTR. It uses the Valgrind option, so it's telling MTR, hey, I want to run this under Valgrind, and it's going to pass 3 options here to Valgrind, and we're going to tell it to check for leaks, which is of course interesting to find our memory leaks. We're going to use the VGDB tool, and that's what we were looking at before there, and we're also going to say VGDB error equals 0, which is basically telling it, okay, as soon as you see any error, I want to start working with VGDB, initialize it straight away. So if you use 0, it will initialize VGDB straight away. If you set it to 1 or 3 or 2 or 3, then it will wait for that amount of errors to be hit. At least that's how I understand it. So great, I've started that, and you can see binaries are debug compiled. That tells us a little bit about the build here, which is great. It's indeed a debug build. Notice, by the way, that this is not a Valgrind instrumented build, but for this particular exercise it doesn't really matter that much. So we're running with these options in Valgrind. We've turned that on Valgrind, and now I just need to quickly swap to another session, even though we got a few minutes, because you know, you can notice it's starting here in MySQLD, and you can see it's quite slow, because otherwise MySQLD would have been long started. So all I have to do here is go to the same directory that we were using and start GDB using the same binary, and I will be connecting to a remote VGDB server, and there's only one running on this machine, so in this case it's not a question of selecting which one. And now you can see that it's saying relaying data between GDB and process 7923. So coming back here, you can see that it's still trying to start. So let's have a look where it's at. Okay, so it's still within the OS side of things, so I'll just go continue and let it run for a few seconds. So as you can see, by the way, it's quite slow in startup. Oh, funnily enough, in this case it started up relatively quickly, but the main point is the server is started here now, and GDB is connected to the VGDB server because it's relaying information here, you can see. And so MySQLD is still running here. Okay, there's 7923, we have Valgrind, we have MySQLD running under Valgrind, and we have the VGDB server started. Okay, so if we hit Ctrl+C here now, we're breaking into MySQLD, and we can see this. Here we can see we're in the MySQLD code. So compare this with, if I'm going to continue, and I'll start yet another session. So in this session we're going to find out what our Valgrind process is, and I notice this is exactly the same if I use MySQLD. There's no extra MySQLD process. Of course, you know, here's your GDB from the other session. So but this is the third session, and now we're going to break in to 7923. And we go backtrace. Why do we get this? Because the debug information from Valgrind is not installed. And just to give you an idea about how we would do that. So I hope you can see the difference between the two items what we're doing here. One is connecting to that internal MySQLD running on the virtual CPU orchestrated by Valgrind, versus what we're doing here is we're connecting directly with GDB to the Valgrind process, which is debugging Valgrind and not MySQLD. Of course, if we would break into Valgrind, everything stops within Valgrind, so that virtual CPU halts, the MySQLD running in that virtual CPU would have halted as a consequence thereof, and we could be debugging GDB, which might be interesting for Valgrind developers, but not for us. So why I'm installing this here is simply to show you how you can get like the debug packages. So you can see sudo debug info install, and you can install the debug package for any particular tool. Remember, Valgrind here in this case is also an optimized binary, and so we need to install the symbol information for the Valgrind package so that we can resolve stacks of Valgrind. So I hope it's not getting too confusing, but for those of you that can still follow, it will be interesting to see this happen live. Okay, so if we now run a backtrace, we can see that we have indeed Valgrind. So these would probably be still the OS side of things, or maybe it's referring to some other utilities. But you can here indeed see it's doing some Valgrind stuff, and you can see here parts of the Valgrind code being called. So this is very different. Here we're connecting with GDB directly to the 7923, and here we were connecting to process 7923 as well, but in this case we're connecting to that internal VGDB server. Okay, so let me simply go out of this, and going out of this will detach the debugger from the Valgrind process, and Valgrind will continue running, which is great. Okay, so you can see detaching from program, Valgrind, it's detaching from the Valgrind program, and even though the process number is the same, that's because you know that Valgrind this is the actual process ID for Valgrind process, whereas here we are communicating between the 7923, which is the same, but we are communicating with the VGDB server running inside the Valgrind process. Okay, so just exit out of this one. Coming back here, so remember we have Valgrind, inside is running a virtual CPU, inside is running MySQLD, and we are using GDB to connect to that MySQLD using the VGDB server that's running inside Valgrind, and the GDB that I was showing you there just on the side was actually connecting to the Valgrind process, which is a very different item. So this GDB could debug the Valgrind process, this GDB we're running here could debug the MySQLD running on that virtual CPU using the VGDB server. Okay, so let me just Control C out of this and do another backtrace. So we're still, you know, just waiting for new connection sockets and whatever in Percona server. So we're just going to continue that and swap back to our other session, and we can still see here our MySQLD is still running, and now we're going to connect to the MySQLD server using a client. So MySQL root, and we're going to have to point it to the socket, which is here. Okay, there's a small typo. Okay, so the MySQL client is great. It's now connected to this MySQLD, which is running under Valgrind on the virtual CPU, and we're just going to initiate a sleep here of 10 seconds. Just before we do this, have a look there at the time, 10:54:24. I'm going to do a 10-second sleep, and we're going to jump back to our VGDB attached GDB debugger. Control C, and this time we're going to have a look at all the threads that are running within MySQLD. Let's just scroll up until we find our sleep process, There it is, and we can see here that's a select sleep that we're running, and we can see that indeed it's sleeping. It's in the function for sleeping. So that's a thread 24, so that's just a thread number that was assigned to that particular client session. And if we go back here now, notice that we're probably way past 24, but the sleep is seemingly still going. But that's not actually the case. What's the case is, because we pressed Ctrl C here, in the GDB session we've halted, just like when we would use GDB --bit, we've halted the process, and it's basically waiting for us to do something here with this process now. So if I go and I say okay, continue, so continue running, and we slot back here, so now it notices that okay, great, it's more than 10 seconds, but look, 10:58, right? So it's completely off. The sleep is quite accurate, and this would not happen. Actually, it's 1 minute 10. So you can see it's been running seemingly for 1 minute and 10 seconds, a little bit more, while we had asked just to run for 10 seconds only. So that's because we broke in and we were debugging, and then we continued it. So you can see how very powerful all this is for debugging to a great degree the MySQL server. So why would we start the VGDB server in the way that we did in the first place? So if you remember the whole setup, why would we not simply connect with GDB to MySQL and debug it like that? Well, that's because first of all, we might sometimes want to run under Valgrind, and of course it gives us via VGDB a possibility of connecting to it. But there's also other reasons, and I'm just quoting this from the Valgrind website. Used in this way, so that means using VGDB. GDB also provides an interactive usage of Valgrind core or tool functionality. So in other words, when we're in our debugging session, we can use all of the Valgrind core or tool functionalities to debug the MySQL running under Valgrind, including incremental leak search under Memcheck and on-demand massive snapshot production. So it's kind of cool, like it gives you extra functionality, and even though it goes quite far for the developers, this might be a great tool once QA has logged a particular issue and this now needs to be debugged. Okay, so let's jump back to our schedule here. So we've had a look into VGDB. In QA, you might sometimes use this. There's a few use cases for which it would be interesting. I would expect that developers might even use it more, but it's there for your use, and that's one way of going about it. Okay, great. So, by the way, think about this as well. Let's say that you have a running MySQL server, and you're in QA, and you have 20 or 30 different machines that are running stuff, and at some point a few of the MySQL Ds seem to be completely hanging. It wasn't just a slowness issue, you waited for a few hours and it's not even progressing a few queries at a time, it's simply just stuck. You can still connect with a client, but that's all about it, and the process list shows just increasing time happening. Now, you might have run this just as a Valgrind run, and you're not seeing this in a debug run. Well, this way with VGDB, you can connect now to the GDB prompt, and you can take a snapshot of the threads. You can probably write a core file, etc. So there is definitely use for this. It wouldn't allow you to do that via the direct GDB, as you remember, because you would be connecting to the Valgrind process and not to MySQL. But using this, you would be able to connect to it just fine. Assuming, of course, that you would have the VGDB server running from the outset. So let's have a look at pQuery Valgrind, and this goes a little bit more into your day-to-day work with Valgrind, how you can do the testing. So for this you need the Percona QA downloads, as we've seen many times. If you haven't got that yet, simply go to your home directory. It's the easiest way to install it there. And branch it from Launchpad, Percona QA, and when you wait a little while it will be there in the Percona QA directory. And of course you have to install the Bazaar BZR tool. Okay, so if we go and have a look at pQuery run, there's a few things that you need to set up if you want to do Valgrind runs. So you want to set Valgrind run equals 1, and you want to point it to debug and usually Valgrind instrumented build. So if you just point it to a debug, you're not going to find much. Just point it to Valgrind build that has been specifically instrumented with Valgrind instrumentation. So it also has this Valgrind command here, which is interesting. So it uses a suppression file from the MySQL test, Valgrind sub, which is there in most distributions of MySQL. And the Valgrind suppression file is there simply because there are some situations where developers say, oh, this issue is completely not important, Valgrind may pick up on it, but it's a known issue, there's no problem, we're going to filter this. So it's like a filter list, and you definitely want to have this in place, because if you don't have it in place, you're going to get lots and lots of issues, and it will be very hard to manage them and to understand exactly what's happening. You also want to pass this numCallers option. It's a little bit slower, I suppose, when you set this higher. Basically, if you have long stacks, and MySQL D is pretty good for having long stacks, then it will go this many frames back to in resolution. Show reachable as yes, so in other words, even if there is a region of reachable memory blocks, still report on it. Usually that's not necessary, but you know, we have it as a little bit of extra here. And track the origins, in other words, track where the issues are coming from, yes. So all the other setup items we've more or less seen in other episodes. You of course want to save the issue only if you run into a Valgrind bug, etc., etc. Oops. Okay, so that's a pQuery run. Once you've done a QA run, and I've got one ready here. Okay, so by now you're fairly familiar with how runs look. So if we run the pQuery results screen, then of course we get the particular issues that we've seen in this run. However, if you run the same with Valgrind as the first option, then it will give the output, but it will also show you the Valgrind issues that it's found. And thank you to my colleague Ramesh, who's added this bit of information in regards Valgrind runs. So let's have a look at trial 118 at the log. So this is just the output log, MySQL D standard error log, where Valgrind is writing its information intermixed with the standard output. So you can see memcheck being initialized, and this must have been run a few days ago while I still had Valgrind 3.9 on machine. And so it gives you the command that it's used to start, and straight away, bang, it runs into some sort of issue here, and you get a nicely resolved stack tray. So if you want to post a bug report, you want to just grab all of this information here, so this whole bit of information, and paste it to a bug report, and that will help the developers tremendously to find out exactly what is happening. So in this particular case, seems something related to join. Yeah, something related to join and to select. So something that's going wrong there. These errors from memory you don't have to worry about too much, but you could go and research them a bit further. And so here we have an invalid read of size 1. And so these two relate, right? They are connected, and they give a different view on the same issue. And so at the end, and that's slightly more interesting, there was a summary. So it's found two particular errors, and there was this many bytes still reachable, and that's that still reachable option that we passed. Normally, I suppose this should always be 0 bytes, but you know, it's quite well known that it's probably not such a big deal if it's probably not such a big deal if there is a little bit of memory still reachable at the end of the program. Okay, so just scrolling down a bit here. Oh, it looks in this case it actually crashed as well. Quite interesting. Oh, something in relation to geometry crash. So the crash might or might not be related to the Valgrind issue seen. Just looking at the stack here, yes, it's also joined. So, you know, in this case it would be very interesting to just upload the whole stack trace, not just this first bit of information, but actually all of it. Oh, actually, and I made a small mistake here. These are 2 different issues. I didn't see this before. So what I meant to say was this and this relates to each other, right? Not this and this, but this and this. So very often you see 5 or 6 lines and then another set of lines here I recall from memory. So, you know, these 2 relate, but this is a different issue, and that's also why we saw 2 errors here at the bottom. And so this and this relates. So I'm used to seeing slightly different stacks. That's probably why I made a mishap there. Okay, cool. So we had 2 Valgrind issues in this particular run, and these can be logged individually and preferably in this case with the whole stack trace, and they do look related here because we have join exec, and just looking, you know, at the very different things. It's also straight after each other. There was no other messages in between. So in any case, you know, you get an idea as to how the Valgrind output would look within the error log and within pQuery results. And so just remember to run that Valgrind option at the end. So basically you go ahead and you just run pQuery pQuery run as normal, but you set that Valgrind option to 1, and this will use Valgrind binary. It will use Valgrind binary with these options that you could change if you like to. It will all run significantly slower. So there is an option here that at the end it says, look, if the and I just recently changed this to use a little bit different code. If Valgrind mode is enabled, then it will run at least 180 seconds. In the beginning it just took the runtime and it multiplied it by 5, but of course if you have a large runtime that doesn't make much sense. We run with a runtime of about 15 to 20 seconds for optimized or debug builds, so you know, in this case we're grinding it an extra 3 minutes on top of that. Because we run so many different trials after each other, it doesn't really matter that we don't have too long a run, but if you just want to run a few, you might want to increase this, or you might just want to set your runtime at to maybe 10 minutes, for example, or even an hour to start with. So, you know, it's all a matter of playing around with it and getting a feel for it as to what significantly covers a particular issue you're looking at. But in general, if you look, let's say that you do 1,000 trials, and each trial is, for instance, the 15-second default runtime plus 180-second Valgrind addition, then, you know, I think that's a significant coverage for a feature. If you want to do it slightly different and you just want to run 1,000 trials at 300 seconds, and so remember that Valgrind automatically adds 180 seconds, that's a very, very significant coverage, right? Or you could say, well, I'll do 100, but I'll let it run for 10 minutes, right? Or an hour, right? etc. Right? So you can play around with it and get a feel for it. If you're just doing general QA, then you just want to use a debug server without Valgrind instrumentation, and maybe do 500 to 1,000 trials on 15 seconds, and that'll be fine. If you, at least for finding out what your major showstopper bugs are and what your major issues are, generally within the space of an hour to 2 hours, myself and my colleague Ramesh would be able to tell you whether a particular release is quality or not quality, and if you want to drill down a bit further into that and get a bit more idea about the features and whatever, would take a bit more setup. But in general, finding showstoppers is not that difficult using the pQuery framework. Okay, so we had a look at how to use Valgrind with pQuery, and we also had a look at the Valgrind stacks, how they look, and how you could go about analyzing them. And of course, with all of these stacks, it's very similar, like standard MySQL T stack. You could grab the first 2 or 3 or 4 frames together, maybe with conditional jump. So you could go conditional jump, inflate, uncompress this particular item, maybe yes, maybe no, and paste that into Google, and you might see the bug report straight away logged and already there. Here in this case, invalid read of size, drop off to 1, because in other cases it might be 2 or 3 or 10 or 50, and just get the first 2 frames here and search for that, and you probably find in Google very quickly the bug report. If it's at least not on some internal bug system, you would find the bug report that's related to the particular issue that you're seeing. So in some cases, of course, you will have definitely lost bytes, indirectly lost, etc. And then the number of errors will reflect your outcome as well. Okay, that's it for the Valgrind run. If you've got any questions, simply post them in the blog post related to this video, the MySQL QA episode 11 video, and we will see them there and answer with as much information as we can. Otherwise, I hope you enjoyed this episode. I hope to see you for episode 12, and especially for episode 13, especially for all the people in QA within the MySQL community, within the MySQL companies that are out there. Come and have a look. If you like it, great, go for it and use it. If you don't like it, that's fine, but come and check out what we might have in store for the future of MySQL QA. God bless.